Okay, guys, in this lesson, we're going to take a look at scatter plots and identify if there is a correlation between the two different variables involved. We're going to learn how to write and utilize a line of best fit. This line of best fit will be written in slope-intercept form. So here's a scatter plot. A scatter plot is just a graph of plotted data points that shows a possible relationship between the two pieces of data. And so in this example, we see that we're comparing how many hours of study that someone studied for the midterm and what grade they made. And in a scatter plot, remember that we do not connect the dots. We're simply seeing if there's a trend. A line of best fit is simply just a representation of the data that's graphed. It can be used to identify other possible pieces of data, and we will write this line of best fit in slope-intercept form, y equals mx plus b. And so in this example, we can see that as folks studied more hours, their grade on their midterm increased. So this would have a positive slope just looking at the data. And then we're going to come up with an equation that represents a line of best fit. So let's talk about the word correlation. It is a measure of the strength of our line of best fit. If the points cluster close together, as we see in the example on the left, we can see these data points cluster very closely together, and therefore we would say this has a strong correlation. In our next example, it still is showing a positive. We can see the data points kind of showing a positive increase going from left to right, but we can see they're scattered a little bit more and they're not clustered close together as our example on the left. So we would describe this as a weak correlation. So the one on the left would be a positive, strong correlation, where the one on the right is a positive but weak correlation. So these are both positive because our scatter points are going up, but the one on the left is strong because they're clustered together, where the one on the right, our data points still have a positive movement, but they are not clustered together. So here are the different types of correlation. So we have strong positive, weak positive. We just went over those two. Then we can have data points showing a negative trend. So as the x's increase, the outputs decrease, showing a downward motion. This would have a negative slope. And they are clustered closely together. So it is strong negative. In our fourth example, again, we have a correlation that is weak and negative. They are going down, they trend down, the data points do, but they're scattered a little bit more. So we say that is a weak negative. And then here where there's no trend at all, so the two different variables that were discussed in this situation would have no correlation. And so they're just scattered all about. There's no trend at all. So a correlation without a scatter plot. When the y values increase, as the x values increase, the trend has a positive correlation. When the output values or the y values decrease, as our x values increase, the trend has a negative correlation. So let's look at study time, which will be our x values, and our output values, our math grade. So ask yourself, as the x values increase, and we will always ask as the x values increase. So as study time increases, what tends to happen to your math average? It tends to go up. So this would have a positive correlation. What about exercise? The more time you exercise, your body weight should go down. So this is a negative correlation. The input, your time of exercising, causes your body weight to decrease. Let's look at our last one. How about the number of pets? The more pets you have, does that have any effect on your math grade? No, that's a bit silly. So we say there's no correlation. So one more time, as you ask yourself, always say, as the X values increase, what happens to the output? So let's look at a graph here that is comparing years of driving and the yearly cost for auto insurance. And then we're going to just sketch in a line of best fit. And this line of best fit will not be probably the same as each one of us that does this. It is simply just an estimate of the data points. Okay, so here we're talking about years of driving. The more years of driving you have, the more experience of driving, the cost of your auto insurance comes down. So when you first learn to drive, you have to pay a lot of money for auto insurance because you don't have experience, and the insurance company knows that you may have an accident. So this has a negative trend. So let's just sketch in a line of best fit. And when we do a line of best fit, we are just going to estimate, okay? And so sometimes we can just find 2 points, so I might just pick this point and then one at the end, and then you want about as many points as you can above and below. So that may not be exactly accurate, but again, a line of best fit is just an estimate. We may should have started down, but I'm just going to leave it right here. So for me, my starting point is $3,200. That's your y-intercept. And then I'm going to find the slope. So I'm just going to locate 2 points, one here and one here. And so this point is 0, 3,200. And then I have another ordered pair, and this is going to be 30, 1,000. So I'm going to find slope. So slope is going to be y2, 1,000, minus y1 over x2 minus x1. And now I'm just going to use my calculator. And so we see that we are going to have a negative slope, which we should, because our line is sloping down. Our correlation is negative, and I'm going to put it just as a decimal. So I got about negative 73.3. So let me just say this one more time. Some of our answers are going to vary. We're just doing an estimate, so just make sure that you have a starting point for your y-intercept, and then you pick 2 points, maybe one at the top of the graph and one at the bottom, and then just find your slope using the slope formula. And now I'm going to put this together, y equals negative 73.3 x plus 3,200. So y is the total cost that I have to pay for auto insurance, and X represents years of driving. So the more years I drive, the less I have to pay. So how much is insurance in 15 years of driving? So we are going to plug in 15 for X. And again, we're just going to use our calculator. So I'm going to say negative 73.3 times 15 plus the 3,200, and we get about 2,150 cents. So this equation allows us to make predictions from our scatter plot here. So it's saying in 15 years, which is about right here, I'm going to pay about 2,100. And yes, that I can see that. That is pretty much accurate. Okay, let's take a look at another example. We can see here that we are looking at hours of gaming and hours of sleep. So we can see that the more hours that a person games in the evening, the less hours of sleep. So as gaming hours increases, hours of sleep decreases. So this is going to have another negative trend. So let's and I'm just going to maybe start. Again, we can just start here. We could start here. I think I will just start like this and kind of go down, pretend that's straight. And again, I don't even have to use a point that is from the data, but this one, I'm going to use this point and maybe this point that's plotted here to find my slope. But here I'm going to start with an hours of sleep. I'm going to start at 7. And then my 2 points is going to be 0, 7. And then I chose 4, 2. And again, we may have different values, but we definitely need to make sure we show that we have a negative trend. And so my slope is going to be y2 minus y1 over x2 minus x1. And this is going to give us negative 5 over 4. I am just going to go ahead and calculate that as a decimal, but absolutely you can leave it as a fraction. So negative 1.25. So as the hours of gaming increases, the hours of sleep go down by an hour and a quarter. So let me write this in white so you can see it. And then we're going to put this together. Y equals negative 1.25 times x plus 7. So Y is total hours of sleep. X is hours of gaming. So how much sleep with 2.5 hours of gaming, will we get? So Y equals negative 1.25 times 2.5 hours of gaming plus 7, our starting point. So I'm going to say negative 1.25 times 2.5, then plus the 7 gives us about 3.875 hours of sleep. And if we look on the graph, 2.5, and then I go up, and it should be about 3 point something, and yes, so that hits exactly right here. Okay, in this example, we see that we have a positive trend. So this time, the more hours that you work, the more earnings that you get. So let's pencil in a line of best fit. Again, you just want your line to be, kind of in between all of these. These are going up by 7. So I'm going just to make sure that I can locate a nice point. So we'll let that be 7. And then again, you're just kind of penciling in, making sure it's like equal. Okay, you don't have to count them, but you have, equal amount of data points on top as you do the bottom of your line of best fit. So again, I'm going to start out at $7. Okay, and then let's pick another point. And again, I can pick a point on my line. I can pick 2 data points. So I think I will go with, let's see, let's just pick something that's very obvious. I'll just pick this point here on my line. So I have 0, 7, and then we also have 3, 56. So our slope is going to be 56 minus 7 over 3 minus 0. And so this is going to give us 49 over 3. 49 divided by 3 is 16.3. So 16.3, and it is positive. So let's write our equation. So for each hour that I work, I make $17.3. And the equation, the total earnings is 16.3 times the amount of hours I work plus the 7 that I just get paid upfront according to our line of best fit. So how much earnings or how much money with 12 hours of work will I have? So Y total earnings 16.3 times 12 hours of work plus the 7 initial amount. And so we have 16.3 times 12, again, just using your calculator. And this gives us $202.60. And one more time, we will probably all have a few different values for each of these because our line of best fit is just an estimate of to create an equation so we can use it to make predictions like we did in our question. Okay, here we have the hours that we spend in the mall and the money in our wallet. So you can see the more hours that we're at the mall, the less money we have in our wallet. So this is a negative correlation. And so let's draw our line of best fit. I'm just going to start here and just go all the way to this point here. So we're going to start out with $500 in our wallet, and let's see how much money that we spend each hour. So I have 0,500, and then I have 6,0. My rate of change, 0 minus 500, and then we have 6 minus 0, and that's going to give us negative 500 over 6, and we know that it needed to be negative. So when we divide this out, we're going to get 83.3, negative 83.3. So each hour we spend $83.30 from our 500 that we start with. So Y is total amount in our wallet. It is not how much we've spent, it's how much is left in the wallet, because at hour 0 we have $500. Now, how much money is left when we have been at the mall for 3 hours? So we have negative 83.3 times 3 plus 500. And this gives us $250.10. Okay, let's take a look and let's practice where we are going to plot our scatter plot and then just determine if it is a weak or strong positive correlation. So number of Instagram posts, so the more we post is the number of likes going to increase. So at 10, we have 2 likes, so these are going up by 5. So we are just going to estimate this, guys. Okay, and then at 10, we have somebody that like has 4 likes, and then at 15 we have 8 likes, and then at 20 posts we have 12, at 25 we have 14, at 25 we have 20, at 30 we have 20, at 40 we have 32, and at 50 posts, we have 34 likes. You can see this has a positive trend. So let's pencil in. Okay, let's pencil in and we'll just start right here. Whoops. And I don't really have a y-intercept here. There was a point here, but I don't think that's from this list. Okay, so let's find slope first of all. So for me, I think we know this is a positive and it looks very strong. They're very clustered together. And so I'm just going to choose a point here and a point here at the end to find slope. And so we're going to say y2 minus y1 over x2 minus x1. So this gives us 32 over 40. So 32 divided by 40 equals 0.8. And then our y-intercept, it's really hard to, it's going to be starting down in the negatives according to this data, okay? So we can just estimate about where that would be. I'm just going to say that would be about -5. And let's put that together. So we have y, total number of likes is 0.8 times how many ever posts that we have, and -5. So we're starting out with negative likes, which is not really possible. And then if we wanted to find out how many likes we would get in 100, okay, if we had 100 posts, how many likes according to our trend line and according to our line of best fit, it looks as though we would have 75 likes. And I hope this helps.